Good morning, everybody. My name is Mike Singletary. I work for the National Cybersecurity Training and Education Center. We're located here in Bellingham, Washington, just south of the Canadian border, north of Seattle, Washington. I'm also also work for the Cybersecurity Center of Excellence for Washington State. We do that for half of my time. But I want to welcome everybody here to our monthly NCyTE membership meeting. And you don't have to be a member to join, of course. And thank you for attending. Today's topic is autonomous and semi-autonomous systems. Since we have folks from all over the United States, and we've been talking about weather, please introduce yourself in the chat. I see somebody's already done that, and let us know what temperature you're encountering today. It's 44 degrees and raining here in Bellingham, Washington. During the presentation, please keep your microphone on mute so that we will be recording, as I said, and that will help with the recording. Use the chat to ask questions. There will be some time at the end of the presentation for you to ask questions. And after today's meeting, the recording will be posted on the web early next week. I want to bring your attention to our next cybersecurity or NCyTE monthly meeting, which is going to be Cybersecurity Apprenticeship Panel. That's going to be on May 19th at 9 a.m. All of our NCyTE monthly meetings are the third Friday of the month at 9 a.m. Pacific time. Next month, we have a Cybersecurity Apprenticeship Panel. Our moderator is going to be Dr. Costas Torregas. And we have panelists from the Community College, Toby West, and we also have Richard Braden from CompTIA, and Kimberly Haig and Abigail Allen, both from the U.S. Department of Labor. This is going to be a really good, I think, informative workshop. There's a lot of industry and businesses who are hiring IT and cybersecurity professionals. Apprenticeships is one way for students to get some experience. And we know sometimes that's hard for especially students in community colleges to obtain. And then the following month on June 16th, we're doing a Max Power Lab demo. We have Christopher Simpson, who's coming from the National University. He has 34 learning objects out on the Clark.Center. So if you're not familiar with the labs that are available on Clark.Center, Christopher is going to go through his learning collection, his objectives and collection that he has on Clark.Center. It's a great resource for faculty who are looking for cybersecurity curriculum.
He hosts those labs that he's going to demonstrate with TryHackMe and on the free labs, not the ones that cost anything.
Okay, thanks for that clarification. And then for some of you, you're not already NCyTE members, I want to encourage you to go ahead and join, become a member. It's easy. You fill out the form and we sign you up. You get access to free curriculum. You get access to our membership meetings. We invite you to attend other conferences. We have travel stipends available for some conferences. So there's a lot of benefits that we have for becoming a member. And we might invite you to give a presentation at our monthly meeting. And just a little bit about our membership. We have 414 member institutions right now across 45 states and 1 U.S. territory, Puerto Rico. And right now about 7,500 contacts, individual contacts. So we do, we're also, if you have something that you want to put out there, we use our social media and our we have our newsletter that goes out monthly, so we can throw that out there for you. Well, there's our benefits. We also have the Cybersecurity Centers of Academic Excellence support. I want to mention that. I heard somebody talking about that earlier. And of course, we have all of the social media feeds. If you're not already signed up for our newsletter, that's our link. Don't worry about writing any of these links down. I'm going to send them in an email after the meeting. With that, I'm going to turn it over to Stephen Miller to introduce our speaker today.
Thanks, Mike, and welcome everyone to our member meeting for NCyTE. I'm the director and professor at Eastern New Mexico University in Ruidoso, New Mexico, for Branch Community College, and I'm a co-PI for NCyTE. So today our guest speaker is Zackary Nicklin, and he's going to cover the anonymous and semi-anonymous systems. So Zach, I'm going to just turn it over to you, let you take over. Thank you.
Yeah, I appreciate it, Stephen and Mike for inviting me here and allowing me to do this. Mind if can I share my screen so I can bring up the presentation? All right, are we seeing the presentation screen? Okay, perfect. So again, as Mike said, my name is Zach Nicklin. I am a co-PI for the National Center for Autonomous Technologies. I also serve as the program manager and primary instructor for all unmanned aircraft systems programs at Northland Community and Technical College in frigid Northwest Minnesota. I'm envious of all you folks in the chat, and I will ask you to please stop rubbing it in for me. We're still cold and snowy here. But thank you all for joining us today. I know that, I was asked to talk about autonomous technologies and some of the roles of cybersecurity in that. And my thought process went, hey, you folks are the experts on cybersecurity. But maybe you don't know as much about the autonomous technologies and semi-autonomous technologies, the roles they play in our society or will play when we talk about the future, the emerging technologies. And then just talking about the different ways that they may communicate, whether it's with each other or with a human. So that's kind of where my presentation is going to be focused today. I'm very much okay with folks asking questions when they have questions. Otherwise, there will be some time at the end. So I will try and monitor the chat a little bit as I go and see if I can address some of those questions kind of as we go as well. So with that, I will get started here. So really, when we talk about these autonomous technologies, again, not a lot of folks really have the insight on how they're used and what they all consist of. And I'm going to give you folks an overview of quite a few systems today, or types of systems, and how they operate, what they do, their essential job functions there, and then, like I said, and then we'll talk about how cybersecurity plays a role in that. So first one up here, we have advanced traditional fixed and rotary wing aircraft. Typically when we talk about your traditional aircraft, we all recognize, I think, that they have autopilot systems on it, and these autopilots they range to different levels. Some are simple wing levelers to where it just makes sure that the aircraft stays in straight and forward flight, right? These days, though, they're becoming more and more advanced. So, for instance, some of Delta's aircraft, as a pilot puts in a discrepancy in their log on their computer, that automatically gets sent down to the Delta Operations Center. And so they're monitoring this type of stuff in real time, setting up, maintenance actions to happen when the aircraft lands, or scheduling maintenance, at a specific facility if it's a much larger type job. On top of that, the traditional autopilot is actually giving way a little bit. And I say that it's becoming more all-encompassing. So if we look at Airbus, for instance, Airbus's A350-1000 just recently in the last couple of years went through its testing phases for autonomous taxi, takeoff, and landing. And when you couple that with the typical autopilot that is traditionally in charge for most of your flights. If you don't know that, I'm sorry to maybe give you a little less than a warm, fuzzy feeling in your heart that the typical commercial airline pilot is not hand flying that aircraft the whole time. It's very much a job of the computer on board that's doing that. So coupling that with the taxi, the takeoff, and the landing, it's all computer controlled. It all has to be programmed. There has to be access to it, and there has to be communication with it. So whether it's between the ground and the aircraft or the computers on board, it's very, very much computer controlled. Moving over to spacecraft here. I think we're all familiar with spacecraft being unmanned typically a lot of the times, right? When we talk about communication satellites and those type of stuff, the exploration type missions where we send off an unmanned probe out to Saturn or out past the edge of our solar system. It's very much unmanned, and it's really only been, in the last couple of decades that we've really been focusing again on manned flights. outside of the Apollo missions, right? Or the space station itself. So with these systems, they're very much autonomous, right? We launch them, we hit a button, and any control that's available and happens from down on the ground with the aircraft, sometimes, hundreds of thousands of miles away or more. And so there's data links that are a part of that, right? So we've got to be able to send this data or these command and control feeds up between the aircraft or the spacecraft up in space and then down on the ground. We're getting more involved in these missions, right? You hear, Elon Musk talking about missions to Mars. We've got NASA talking about, I believe it's their Artemis missions, where they're going to be resending people, up to the moon again. But all of these have some ability of control and communication, down to the ground, and they're susceptible, right? Anytime that we have a message or communication, a control or command sent through airspace or through the space, then it's susceptible to interception, it's susceptible to jamming, and it's susceptible to somebody jumping on and getting a free ride for their own command and control data. So autonomous maritime vehicles, you see these in a lot of different functions. So when we talk about even the very, very large cargo haulers, so they have the big 20-ton CEU containerized shipping, right? Most of those are very heavily computer controlled, even when they have folks on board. And now we're talking about unmanned cargo ships that'll be able to cross the Atlantic with hundreds of thousands of tons of cargo, some of that cargo being hazardous materials, and then being able to dock on the other end. Further, we're talking about Coast Guard patrols that are using this type of stuff in order to do basic maritime patrols, whether it's search and rescue, coastal defense, that type of thing, drug interdiction. Now, granted, we're going to need people as a part of those, but these autonomous maritime vehicles are very much a part of it. When you look at what the Navy's doing, the Navy's using them to find mines, to be able to find enemy submarines and things like that in the area. So it's more and more we're relying on this technology, throughout our life here. You can see in the next one here, we got the driverless cargo trucks. Maybe you saw a little bit of something about it, from Tesla. Not sure how well that one's worked out, but there are multiple organizations from Volvo and Peterbilt and all those big names. They're talking about these driverless cargo trucks. Now, these driverless cargo trucks, we can find, more and more on our roads. They've been doing cross-country testing, where they actually have a chase vehicle, or they'll have somebody sitting up in the cab, not touching the controls and just monitoring. But as this technology becomes proofed and becomes, tried, true, and trusted, we're going to see more and more of this. Well, all of these semis, they're carrying goods, sometimes very expensive goods, sometimes they're carrying hazmat materials. Further, as more and more of these get on the road, the idea is they're supposed to start talking to each other on top of just being able to sense the road with its own sensors, but being able to actually speak to other cars on the road and other trucks on the road and allow for separation. So, when we talk about the passenger vehicles, and I've got one on the next screen here that we'll talk a little bit about more, but these vehicles, they're covered in sensors, right? And all these sensors are talking back to a computer. It's telling it, is it still in its lane? Is there another car in what would traditionally be a blind spot, right? I don't know if we can call it a blind spot anymore if it's covered by a sensor and there's no person to miss seeing something there. So it's got these sensors, and it's LiDAR and proximity sensors. You've got camera sensors where it's using AI and machine learning to be able to categorize the type of objects that it sees, to be able to judge risk, right? Is this object likely to move in the path of travel? And then having that vehicle automatically respond to it. You have a kid kick a soccer ball into the middle of the road, having the driverless vehicle understand that, A, there's an object in the road, and B, there might be somebody following that, right? Because we've all seen in the news accidents of that type where, the kids just running into the road, not really thinking to go grab their ball or some other object. And so All of this is happening at once, and it's bringing in all this information. But on top of that, they're also talking about using things like 5G to be able to, again, have constant communication with this, to allow some operator back at a dispatch or an overall control center to be able to locate all the vehicles, do basic monitoring of systems and system health. But again, that opens up another area, whether we're talking about an actual hack. And I apologize, I'm again not a cybersecurity guy, so that might not even be the right term we're looking at. But actually getting into the computer systems and being able to send signals to tell it to do something that it shouldn't do, but also being able to fool the individual sensors on the air or on the vehicle itself. So for instance, when we talk about like GPS spoofing, that type of stuff, we've got to be able to secure this to make it safe for everyone. Because frankly, especially when we talk about new and emerging technologies, it's really the news reports that fully affect the public, right? And you don't get widespread news reports about, hey, we did a great test where it drove for 1,000 miles and didn't hit anything and stayed in its lane and did exactly what it was supposed to do. But the first time somebody gets hit or there's some other type of accident, think about like Tesla's self-driving feature, where folks were not following the manufacturer's recommendations, and we're actually letting the vehicle not only drive itself, but reading a book or doing something else like taking a nap, and wind up getting an accident. That's what everybody hears about. And when that type of thing happens, the immediate negative publicity will have a huge effect on the adoption of this, even though overall, once we get some of these technologies out there, it's going to provide for safer operations. The reality is that when we look at semi accidents and car accidents, almost all of them are human error. Human error being that one thing that we really don't have a lot of control of, because everybody's different and some people don't pay as much attention as they can or as they should. So having these vehicles all talking to each other will eventually make things much safer. However, we have to make sure that all of the command and control links, all of the functionality of the vehicle is not susceptible to any, I guess I wouldn't say enemy, but any person trying to use it for its own means in a way that it shouldn't be, we'll say. Advanced air mobility is another one that's being talked about more and more these days. I think everybody's heard about UAS or small UAS. Everybody knows somebody with a little quadcopter, but with this advanced air mobility and urban air mobility, which is the UAM portion of it, is we're really looking at kind of air taxi services. And there are companies out there that are currently working through the certification process to get these out there. And the idea is that when you're commuting from a suburban area into an urban area, if any of you folks live in those type of areas and make that commute, you understand that rush hour traffic can be, really, really extend the amount of time that you spend in your vehicle and the amount of time that you spend on your commutes in the morning and in the afternoon. Advanced air mobility and urban air mobility are looking at ways to reduce that traffic, right? And it's gonna help in two ways. One, those with access to urban air mobility or advanced air mobility type services will obviously not have their car on the road. So as the sky becomes maybe a little bit more congested, the ground will also become a little bit less congested during those. So it's kind of a win-win for everybody if it all works out. Further, we're looking at ambulance type services. How many times do you get an ambulance that's stuck in traffic? And I know, they've got their lights and sirens and everybody's supposed to get out of the way. But I think we've all, spent some time on the road and seen instances where traffic was so bad that the ambulance is creeping along, and waiting on folks to get out of their way, or you have folks not paying attention and sitting in their way. If we could dispatch an ambulance that could land in somebody's front yard and get them loaded up and back to the hospital, we'd be decreasing travel time, not only to get on the scene, so you can get your response faster, you can get your immediate aid faster, but also getting you to a trauma center or something like that that's necessary, much faster as well. So as we talk about this and You know, it's not only in an urban environment that they're talking about doing that, they're even talking about small regional jumps. So if you've got there's plenty of commuter aircraft out there that, you know, they take 30 to 45-minute flights, and it's fairly common out to smaller airports. You know, advanced air mobility would be able to, you know, decrease the amount of those, or I'm sorry, they'll be able to get there faster, burning less fuels. And right now, a lot of these systems, the way they're testing them with pilots in them. You know, so as they go through and they get certification through the FAA, they're getting certified as a piloted aircraft. But all the initial tests on them are all done with nobody in the cockpit. They're all done autonomously, they're unmanned or remotely. And the idea is if they eventually, that's their goal, is to be able to offer these services in a way that doesn't take a pilot on board. With the current state of regulations around, you know, aircraft in our airspace from the FAA, the Federal Aviation Administration, you have to jump through a whole lot more hoops to get to there. So right now, these companies are doing it in a way where they put a pilot in the seat, but the pilot may not, again, actually be flying, just like our traditional commercial planes. So they'd be relying on the computers on board, on the data link from a control center to tell that aircraft where to go or when to go there. Coupled with, of course, onboard sensors to be able to sense and avoid other aircraft. As I was talking about with the trucks, they're also talking about with the advanced air mobility, with the ability for these different air vehicles to talk to each other and allow for self-separation. So they would actually determine themselves, you know, do I need to turn slightly left or right? Do I need to gain altitude or lose altitude jointly with this other aircraft in their airspace to determine the best way to avoid any type of collisions or near misses. So again, very, very heavy on the technology, very heavily reliant on wireless communication in order to either take direction or provide updates. Moving forward some more, we have the autonomous underwater vehicles. All shapes and sizes, all types of missions, everything from the fiber optic line inspection. So if I'm fairly certain this group is aware, but you know, we're not connected via satellite to everybody. Most of our connections that go from one continent to another rely on heavy fiber optic lines that are laid across the bottom of the ocean, or other cables laid across the bottom of the ocean. And so these type of vehicles are used to inspect those. Sometimes they're used to move and adjust their placement, to lay them down in the first place and ensure they're being laid down correctly. We use them to image the bottom to determine the best places to lay these cables. And that's just one of the jobs on top of, you know, we've got, you know, oil lines and out there in, for instance, the Gulf, you've got all of the oil wells that are out there, with a lot of the infrastructure for those being underneath the surface. They rely on vehicles like these to conduct inspections and let us know when we need to send down a team to fix it. As technology has been progressing, some of these systems are even providing them those repairs themselves. So there are autonomous welding machines that would go down and be able to weld underwater or weld parts of ships back together. We use them for exploration. The military uses stuff like this heavily, again, for mine detection, for subsurface detection of enemy vehicles that may be hiding under the water. We use them for scientific research. You know, where's the thermocline at? How's the salinity in this section? Are there any type of pollutants that can be identified? So there's many uses for autonomous underwater vehicles. We use them here in Minnesota and other places in freshwater environments, mapping the bottoms of lakes, being able to make sure that our waterways have sufficient clearance for the type of vessels that go through there. So they're, like I said, used extensively, many different ways. And, you know, all of this is done typically with the underwater ones. It's not a live connection. Typically, those are pre-programmed and sent on their way. But there are ways that you can communicate with it and get updates from it. It's not maybe as robust as communication through the air, because the environment of the water doesn't necessarily allow for that. But being able to hijack control of some of these especially when you think about one welding underwater on an oil rig. I mean, there can be a huge environmental impact to the wrong character getting a hold of something like that and being able to use it for their means. With UAS, we're talking unmanned aircraft systems. Again, I think folks are fairly familiar with the small stuff, you know, the little DJI Phantoms and things like that that are being used for real estate pictures. But these days, look at what's going on over in Ukraine with small UAS. They're using commercial off-the-shelf aircraft, modifying them and basically arming them with munitions that can be dropped on enemy soldiers. There's nothing to say that this type of stuff couldn't be done with the aircraft that we have here and that are used. You know, you can go to Best Buy and pick some of those up. Further, the aircraft themselves, some of them either have fuel, they have lipo batteries, which are highly flammable. They can be, you know, packed with explosives, that type of stuff. So making sure that we have a good command and control link for that type of stuff, even the little small stuff that we think of as almost toys, you know, is a very important concept that, frankly, I don't think we're doing the best job with. As we look at larger unmanned aircraft systems right now, most of those typically tend to be in the DoD realm. There are some outliers, you know, NASA, NOAA, the National Oceanic and Atmospheric Administration, you know, they're both using very large unmanned aircraft to do simple things like, you know, imaging the Arctic and looking for the thickness of the ice sheets, flying into hurricanes and getting sensor data of the hurricane, you know, whether it's barometric pressure, wind speeds, all that fun stuff, rather than sending in people. But primarily they're being used by the Department of Defense. And I think we've all seen on the news, you know, the Predators and Reaper type aircraft, you know, they're armed aircraft, 60-foot wingspan, full of fuel, got combustion engines on them. And, you know, the DoD does a little bit better job, I think, on the cyber realm and protecting those data links. But as the FAA starts opening up the airspace to some of this larger stuff. So if you're not aware right now, the only commercial operations done in our national airspace system with UAS are relegated to small UAS, which is under 55 pounds, or very rare exceptions. The idea from the FAA is that they're slowly integrating, starting with the small stuff, but they're talking about possible new regulations coming out as early as September that's going to allow heavier aircraft to be able to fly beyond visual line of sight. So right now, again, with the small stuff, it's you're supposed to stay within visual line of sight, which means you know a little bit better when your aircraft is not acting the way it's supposed to. As we push it out beyond visual line of sight, you become heavily reliant on the data that the aircraft is sending back to you to determine where it is, whether it's on mission, whether it's at the altitude that it's supposed to be. And we have to trust that the information we're getting back from the aircraft is correct. Otherwise, we could cause issues, you know, between other aircraft, between, you know, God forbid, an unmanned aircraft and an airliner or something like that. So that becomes less trustworthy when we don't spend as much time securing those data links. And with the small UAS, the data links really are just not as secure as they should be. But again, as the FAA opens up this airspace and we start talking about agricultural crop dusters, for instance, you know, you have to get a special license to be a crop duster in order to apply chemicals. And part of that is the background checks and making sure that you're doing the right thing. Being able to weaponize a traditional crop duster that can hold hundreds of gallons of whatever's put in it. You know, we typically see fertilizer and pesticides, things like that. But there's, you know, there's nothing to say that a bad actor could not, you know, fill it with something else. And now they don't even have to sit in the cockpit and fly the mission themselves. They can do it from, you know, an anonymous computer terminal anywhere in the world using satellite systems. So as these systems start to proliferate and become more ubiquitous within our national airspace system, there's going to need to be I guess a deeper dive into the cybersecurity aspect and to make sure that we secure those command and control links, making sure that we secure the data both going to and from these aircrafts.
I'm only in the listen mode.
Where's Dudesy?
What's that?
Where's the boots?
Oh, sorry, Tom. I think you're unmuted there. I thought you were asking a question at first there.
No, I apologize.
Yeah, no worries. So, Luca is our large unmanned cargo aircraft. So if you think about let's see, what was it? It was the Tom Hanks movie where he got Castaway. That was the word. So you look at a big FedEx cargo plane essentially flying between places like China and America. Most of the flight is conducted over water, where there's no real population there, and what population there is transient on ships. These type of aircraft are essentially wasted space for when it comes to people, right? We'll put a crew in these aircraft for these long haul flights. Excuse me. That crew could be 4 people or more in order to provide crew rest. So we've got the seats for crew. We've got all the facilities for crew, whether it comes the kitchen and the refrigerator and the restroom. Then we talk about the life support systems for those crew. So we got the oxygen systems and things like that. And then all the control hardware that's in those. If we were to take all of those out of your typical FedEx long haul flight, there'd be hundreds and hundreds of pounds that we could either add more fuel or add more cargo, do the same job much more efficiently. There are organizations such as FedEx and UPS looking at making some of these systems unmanned for that specific reason. Again, then you've got some added problems there, right? When we're flying from China to the US or any other nation to the US with an aircraft that's capable of holding tons of cargo into our airspace or within them as they fly into our airspace. So when it comes to that, I think most of us remember or at least know about 9/11, right? Those were typical passenger airplanes that were heavily loaded with fuel. And it took a person on board to actually, cause that incident, right? They took over the aircraft and manually crashed it. It becomes a whole lot easier if all I have to do is get a data link. I don't have to convince somebody to get on that airplane and physically crash it and cause a lot of damage. So again, security, not just physical security of the aircraft and the airports that we're using, things like that are very important. But even being able to get a hold of the command and control links to be able to take it over and be able to command that aircraft to do something like that, or God forbid worse. It's a very important thing that we need to keep in mind, and we need to figure out ways that we really are able to secure these systems and make sure that they provide the benefit that we know they can, right? That's the reason why we're going after these systems, why we're looking at introducing them and making them. It's because they're going to provide a benefit to society in some way, shape, or form. And if it doesn't provide a benefit, we wouldn't be doing it. But the integration of these type of things always, introduces an ability from a bad actor to be able to, do things they shouldn't be doing with it. So last couple of examples I'll give you here. Here's our driverless passenger vehicles, and I kind of mentioned this a little bit with the trucks. I threw some of the sensors or took a picture that shows some of the sensors there. It's LiDAR, it's proximity sensors, it's a LiDAR light detection and ranging. It's using camera systems, it's using AI. Everything on these systems, of any of the ones that I've talked about, they're very heavily computer controlled, and they're reliant on that computer and those sensors, both the internal sensors to sense the state of the vehicle, or the external sensors to basically be able to understand its environment, all heavily computer controlled. As we talked again about the driverless passenger vehicles, as we've been talking about smart cities, things like that, what they are talking about is these vehicles being able to talk freely with each other, which is great because then they know the distance between each other. They can share information about road conditions. If you think about a car coming from one way and you're going the other way, that car can send over information to your car about road conditions ahead that you otherwise wouldn't know until you got much closer. And that all sounds great. It all sounds a way to make things safer. But what if you have a bad actor in that car coming towards you, and it sends you information to say that the road is clear and dry ahead, when in actuality there's black ice in parts of it, or there's snowy or water covered, whatever it may be. There's a chance that you can cause issues and cause loss of life. And so again, the cybersecurity aspect is going to be very, very important. I know with small UAS, there's been a big push lately about moving away from Chinese products. And I'm not sure if you folks have been following any of that, but there's been legislation put in place that's stopping some federal funding from going to those type of aircraft. And it's all about the aircraft communicating back with servers in China and providing information. There's kind of a 50-50 mix about what folks think about that. There's definitely a large group that says, well, they've already got spy satellites, they've already got people within the country. There's nothing to stop somebody to go get their license for being able to fly a small UAS and being able to capture some of this information themselves and physically send it over. The other side is well, let's not make it easier for them, right? I'd say that a good portion, 95% or more of the flights of small UAS, even those that are manufactured in China and maybe communicating with a server back there, they're not capturing any novel information. When I go out and fly to the local farmer's field and tell him his crop health, it's the same information that you can get from satellites. It's just on the satellites, it's much more delayed, right? And maybe not as granular. So again, there's two ways of thinking when it comes to that. But the federal government is absolutely starting to crack down and find ways to reduce that type of reliance. But when we look at a lot of the chips that are used in all of these technologies and the sensors that are used, a lot of this stuff is really already coming from states or from countries like China. So I'm curious to see where things are going to go if we're going to pick up some of the manufacturing ourselves, and so that way we can guarantee that it's a little more secure. But either way, I think there's going to be a large role for not only data management, but really for cybersecurity and in securing these things from the beginning to the end, right? I don't need to take over your drone if I can simply break into the factory that's producing the flight controller for it and be able to hijack the software at some point that way. Industrial robotics are something that's becoming more and more common, whether it's actually building your car by putting panels into place and doing welding. There's a company right down the road from us called DigiKey, and if you buy electronic components frequently, you may know of them. But they've actually just revolutionized their new product distribution facility, where almost everything is computer controlled except for the final packing and shipping. So all of the components sit up in racks that the workers there don't even go into. An order comes in, the system goes and pulls the buckets with the correct components, brings it down a conveyor throughout the entire place where it gets to a person who double checks it, packs it, boxes it, put it back on a conveyor, and then it automatically gets scanned and sent to the correct shipping agency, right? This stuff is becoming more and more common, whether it's taking inventory, actually building stuff, where we use industrial robotics or robots even on the space station. They've been testing robots to help out the astronauts up there. So being able, again, to secure them, it becomes a really big deal. And the last I wanted to show you, just because it was really interesting to me, is autonomous tugs. So if you ever sat in an aircraft and waited for a tug, and you got some guy who comes out and hooks up a tow bar and brings the aircraft out from the gate level, they're actually starting to find ways to introduce these autonomous tugs that when the pilot's ready, they simply make a call and a tug will come, hook up all by itself, and not only pull it out of the gate area, but now they're talking about using them to actually taxi to the edge of the runway as well, with the idea that the more time they can wait between starting their engine, you reduce the carbon footprint, you reduce the cost. Even sitting in idle, those aircraft don't exactly sip fuel. And so these are, becoming pretty prevalent. And I know there's experiments from multiple different companies that are out there using this type of technology to be able to provide a proof of concept with the idea of integrating this at airports across the country and across the world. So again, that one I just thought was kind of cool, but if you were to get a hold of one of those and run it through a line of airplanes at the gate, obviously you can cause a lot of damage there. Even if it wasn't, if you didn't do it on purpose, right? You accidentally got into one of those and gave it a wrong command, that type of thing. So, like I said, there's tons of different technologies out there, whether they're fully autonomous, semi-autonomous, that we're integrating, and all of them rely on some type of computer interface, some kind of data link between the controller, whether they're actively controlling or simply monitoring, and the vehicle itself. Everywhere from underwater to on the ground, in our airspace, or in space itself. And so you folks, or the folks that you folks wind up teaching, are going to be an important stopgap or firewall to be able to ensure that this stuff remains safe for use and allows for adoption of this technology that's going to make our lives easier, that's going to do more dangerous jobs for us, keep our folks safer, or of course reduce our costs as we start running businesses. So with that, I left this in here just because I think AAM is about the coolest thing out there. So I gave you some links about some of the stuff going on. I can tell you, so if you look at the Joby Aviation S4, this is in the middle of certification testing. They're talking about operations here within the next year. The Jetson 1 here is actually a flying car. Is actually a one-person flying car, essentially. They can go, I think it's 60 or 90 miles an hour for under $90,000. It's just amazing. And then if you look at the very first one, the Ital Design Airbus pop-up, the concept on this one actually is that you've got a chassis that's essentially shareable. So you can drive your vehicle, or it can autonomously drive itself to a certain point, and then be able to take off and leave the chassis on the ground, and then go and suit itself into another chassis as it gets to whatever other area that it needed to go to. So like I said, just some really cool concepts that I thought maybe you folks would enjoy exploring if it's something that interests you. And at that, I will stop my share, and I'll ask if there's any questions of me. And I'd love to hear your thoughts on cybersecurity on these, and what we can do to make sure that we stay ahead of that curve.
Great presentation, Zachary. Anyone have any questions? I have a few, but I'm going to let you all ask first if you want, if you have a question. I have a couple of things I was thinking about as you were going through your presentation, which a lot of that I didn't really know about, but some of it I was aware of. I mentioned my son's on tankers, and he's a captain and a pilot on a tanker. So they actually have everything computerized, and they go through the New York Harbor fully loaded with the gasoline or whatnot. So that's a bomb going through the harbor. So and I'd always ask him, I said, well, what kind of procedures do you have in place, like for disaster recovery, business continuity, as far as can you take over control if somebody took control of the craft itself? And so that leads me to, are these manufacturers kind of manufacturing these components and whatnot with security in mind, or do you have any idea about that?
I'd say it really depends. As you get to the larger stuff and the stuff that's more DoD centric, that's obviously a big requirement from the Department of Defense, is addressing that. A lot of the commercial stuff, though, it's really not. It's not hardened in any real way. We're relying a lot on relatively untrained folks. If you look again at the small UAS, anybody can go to Best Buy and pick one up. No cybersecurity training, no, half of them probably don't have any antivirus software on the cell phone used to control it. So I think that you folks as cybersecurity folks know that one of the weakest links in that chain typically is the human. And, when we talk about social engineering and phishing and those type of things, we are just as susceptible as the average company. And the average company might spend, hundreds of thousands or even millions, as we talk about larger companies, of dollars on this training to say, again, stop clicking those links in your email. And somebody still does it all the time.
Yeah, that's true. We actually work with our with one of our high schools, and they do a lot of they actually program the drones, and then so what we've been doing with them, they use Adreno computers that they program with C++, and then we help them put the security and the net and especially the network type security in there, so they at least understand that these devices need to be secure, and a group of them try to break the other ones, which sometimes is not much fun because they destroy the drone.
It's still an important concept to get, and it's better destroying a $100 or $200 drone in a classroom than it is to crash a $200 million global hawk or something like that. So
Yeah, we hooked one in the blinds at the high school. So, if anybody have any questions? I mean, this is really, I think, a key area. I know that there was the NSA used to have this it was a PR type thing to talk or to help students understand how the NSA works, and they had this. It was a day in cyber for the NSA, and they had a team of 7 people that were managing drones that were in Afghanistan, and they showed how this drone was hacked into, and then it was they took control of it, and then this team had to get control back of the drone, and then how they had to handle all of that. So it's pretty interesting. They had like a team of 7 people. They had a person that did reverse engineering. Of course, they had a team leader. They had some expert on the drone controls and whatnot. I mean, it was a pretty interesting video, and so it kind of brought that attention to drones. That's how we started doing this stuff with the high school, was thinking about that. We actually showed them that video, and they started getting interested in drones. Let's see what's in the chat. Let's see. There's a question in the chat.
Yeah, so looking at the standards that would govern these systems, specifically around cybersecurity, well, I can tell you that ASTM has a lot of stuff on UAS. SAE. I'm not familiar with the other one that you call out there, but the reality is a lot of times within these committees that are working on them, they could always use more folks who really understand cybersecurity on these committees. So for instance, I know ASTM, all of the standards that they do are consensus-based standards. And so they reach out and they try and get, SMEs, subject matter experts as a part of it. But, sometimes it moves forward without the amount of representation that maybe we'd like to see. So I guess I challenge some of you folks to reach out to organizations like ASTM's F-38 committee, which is the committee on unmanned aircraft systems standards, and look into either the cybersecurity standards that exist, or if there's not, reach out to the committee chair and get some going. And if anybody would like help with that, I know the folks there at ASTM F-38, and I'd happily provide introductions and getting you folks in there. I think that'd be very important.
That sounds good.
Yeah, this is
One question.
Park in
Go
Omaha,
ahead.
Nebraska. Yeah, you're right. The past year and a half, I've had a huge campaign at our college to not send an internet link cold in an email or a QR code because of the threat. And believe it or not, our HR listened to me because they were sending out links like that for PayFlex, for training and things like that. And so they met with me and they said, well, what do we do? So the system we use is called My Way. So I told him you put it inside of my way, and the email that goes out directs the user to go log into my way. So they have to authenticate to a secondary system to get to the internet link. So it reduces that footprint quite a bit.
No, that's great. And then you don't have folks that you can make sure that they know full well that if it doesn't go through my way, it's not a link to click, right? So no, that's great. That's a good way. And I'm glad to hear that your HR department has implemented that.
Well, then too, one of the things I use is for education, training, and awareness. I use the out of office assistant in Outlook. So I put a security tip in there. Anybody who sends me an email, they automatically get a tip whether they want it or not.
I'm going to put a plug in here too. Zach, you've been talking about like how we need to be aware of what's going on, but you know, teaching cybersecurity across a discipline is something that we're seeing more and more as an evolving part of all disciplines. I mean, it's not just one area that teaches cybersecurity anymore. So I'm curious about if you're starting to integrate elements of cybersecurity into your teaching, and you know, are students becoming more aware of what the risks are, and you know, how you're upskilling them for that?
Yeah, so we've always included just a little bit about cybersecurity in there. I'd like to see something a little more formal, and I do have plans to integrate that. We just got done in ASTM, in one of the ASTM committees, creating a UAS maintenance technician qualification standard. And as a part of that, the knowledge required, knowledge, skills, and abilities that we had identified, one of them was at least the basic concepts of cybersecurity. So I'm going to, and that was just published here in January. So the update hasn't made it into the coursework yet, as far as in a more formal way. And so we do have a cybersecurity program here on campus at Northland. And I do plan on going to talk to the instructor there and see what we can do about maybe at least putting a solid module together again to formalize it a little bit about it. I know our students as maintenance technicians, you know, would not be the cybersecurity experts. However, they do need to understand the basics of cybersecurity and make sure that they're not the person clicking that link or plugging in a thumb drive that they just found on the street, you know, that type of thing. So
Stephen's going to plug our SciAD event.
So, yeah, we have the SciAD, the Cybersecurity Across Disciplines conference, August the 1st and the 2nd at Marine Valley Community College. And I put a link in there. If you're interested, you can click on there and click the interested key, and you'll get some more information and be able to sign up. We're actually taking, I think they're going out for call for presentations as well. But what the SciAD is going to provide is a comprehensive review of cyber for other disciplines, and then those other disciplines to talk about how those disciplines work, and then what needs are needed, what we need as far as education, and how to incorporate cybersecurity into those different curriculum. And then we can also incorporate in our curriculum for cyber good examples of industry sector scenarios. So check that out. There we go. And call for
Screenshot
proposals
up there.
Yeah, thanks, Mike. So Zach, thank you for a great presentation. I think it's a lot for us to think about, and it's really cyber covers crosses all types of disciplines. So that's where why we're focusing on a SciAD to help kind of promote that. So thank you again, and thanks everyone for attending. Mike, you have any closing?
I threw the link out there. Please fill out the survey. Your input is really important. We try to bring topics that are really relevant to cybersecurity, and we put this together every year. So your input is super important. So please fill out the link. It only takes a few minutes. I appreciate that.
Hope to see you at Marine Valley.
Yeah. Take care, everybody. Have a great day.
Weekend.